All right, guys. So who knows what this year's going to bring, but we are going to keep going because we have things to learn, and that is life. So we're going to talk today about how to take a base that has a fractional exponent and how to turn that into something that is a radical. So basically, any base to a fractional power can be converted through this form. So if we have a to the power of b over c, we've got some vocabulary here. So a is going to be our base number. So the c here is going to be our root. It's going to be the type of index that we have, or the number on our index. So the way that I think about this is things are rooted into the ground. So it's on the bottom part of the fraction. It roots the fraction. And then this here is going to be your power. So it is going to be what goes on, it's going to be the exponent of the base. And then this is going to be your index. So basically it becomes C. That's going to be your index right there on your radical. And then you're going to have A to the power of B. So that's basically the form that we're going to be working in right now for how to convert these fraction exponents into radicals. So what this is going to become right here is we have a base of 3. No, we don't. Yes, we do. We have a base of 3. And it has a power of 6 and a root of 5. So what this is going to turn into for us is we're going to have a fifth root here, and it's going to be the fifth root of 3 to the power of 6. So right now they've asked us, so it's asking us, your book asks you to identify the power and to identify the root. Well, 6 is our power, 5 is our root. And so that's one way that we can express this. Now, most of you know that this can be simplified, so don't think that this is simplified. It's not. This would technically simplify to 3 to the fifth root of 3, right? But it asked us to take this and write it in radical form. So this is it written in radical form. So the next thing that it asks us to do is in part 3, it asks us to write it in these two different forms here. So the first form that it's asking you to look at is one where you have the root and you here, which that makes sense. Our root is our index, and we have our base and our power. So that is the one that we've already done. That's the one where we have the fifth root of 3 to the power of 6. And the next one is one where we have in parentheses, we have our root, we have our base, and then the entire thing is raised to our power. So if we're going to take this, that's going to be a fifth root of 3, but that entire thing is being raised to the power of 6. So that is how we deal with rewriting from going from fraction form to radical form. So example 2 here gives us a radical expression, and it wants us to write it as an exponential expression. So that just means using an exponent. So when we look here, we currently have 8 to the power, so we have the 8th root of a to the power of c. So this right here is going to be our power. This is going to be our base. This, our index is our root. So we know when we write our fraction, we have our base is obviously where the base goes. Then our root is the denominator, so we're going to have 8 here, and then our power is the numerator of our fraction. So when I convert this radical expression to an exponential expression, I get a to the power of c over 8. All right, so the next one here is asking you to evaluate the expression and to round your answer to the nearest thousandth. So that's going to require that we have a calculator. So if you have a calculator, go ahead and grab one. If not, stay tuned. We'll figure out what to do. I'm sure that you can do this in Desmos. So if you want to explore that, I guarantee you that there's a way to do that there and that it's not hard to figure out. So if you have your calculator, one of the things I want to do is talk about the different ways that we can write this and look at this, and obviously they're all going to be equivalent. So right now you have the eighth root of 4 to the power of 10. So this, if we think about this, we have 10 fours here. So really, that's going to be the same as 4. Well, I don't know why I made that so small. Because we're pulling out an entire 4. And then we're going to have an eighth root, and then we're still going to have 2 fours left. So that would give us 4 squared. So these right here are already going to be equivalent in value. So this would really give us 4 to the 8th root of 16. So if you have your calculator, just for fun, we know that 4 to the 10th power, well, I guess we don't know what 4 to the 10th power is, but I can use my calculator to evaluate that 4 to the 10th power is actually 1,048,576. So I'm going to put that there, 576. And I'm going to go ahead and put that in my calculator and see what I get. So the way that I do that is I press 8. And then I enter an 8 into my calculator. Then I press math. Then I go and I press the number 5. And now I've pulled together an eighth root. So I'm going to put in 1,048,576. And I get a decimal value. It says to the nearest thousandth. So this is going to be 5 and 657 thousandths. So another way that I can do this is I know that this is the eighth root of 16 times 4. So I can hit in my calculator, I can type 4, I can open up some parentheses. I'm going to put 8, math, 5, and I'm going to put 16 there. And I'm going to close up those parentheses. And sure enough, I'm going to get the exact same answer because those are equivalent values. So that would again be 5 and 657 thousandths. And then now, using our knowledge of converting radicals to exponents, we know that this is going to have a base of 4. We know that our power is going to be 10 over a base of, or a root of 8, so it's going to be 10 over 8. So we can take our calculator and we can do 4 to the power of 10 over 8. And sure enough, we get the exact same thing. And I'm sure some of you are already asking, is this the same thing as 4 to the power of 5 over 4? And it sure is. So if you use your calculator here to do some analyzing, you're going to find that you have a lot of values that are similar. So, and are not just similar, but equivalent. So this here is equivalent to this, which is equivalent to this, which is equivalent to this, which is also equivalent to this. So pretty soon we're going to be working back and forth with some more notes there. Right now, you can go ahead and pause. All right, so sorry, I had to pause to get myself together to figure out what we were doing next. So those were the 3 examples. So now you should be on page 255. So at this point, you should have already done lesson 3.2. You should have already completed the homework for lesson 3.2. You should have already watched the video going through the solutions to homework 3.2. If you had a question that you wanted me to work out, you should have already emailed me that question. So now we're starting on homework 3.3. So looking here, this one is just asking you to take these and convert them. Um, and that's that. So think about what that means to have a negative and how you can pull that out, how you can factor that out of something. And it says do not evaluate. So it means it does not need a decimal value. So these ones are just asking you to take these radicals and convert them to exponential expressions. It says you don't need to evaluate. These ones are asking you to evaluate. So you can use your calculators, but then for each one, I want you to rewrite it a different way and then find it again using your calculator just to prove that they're equivalent values. Then you can go ahead and flip over to page 256. And on page 256, they're just having you look at a couple different things here, thinking about these rules. So go ahead and complete those. And when I post the answers, I'll post some explanations, some rules, looking at why some things work. And then for this one, I want you to complete as the directions are given there. So go ahead and complete those. And then what'll happen is I'll post another video. And honestly, the challenging ones I'm going to talk through as I present the solutions anyway. So tune back in tomorrow and you can get the answers to your homework. Again, I hope you guys are doing well. I appreciate you staying engaged. Go ahead and get this done, and then we're going to look at some more questions that involve this same concept tomorrow. All right, bye.